here are some of the PowerPoint problems in chapter 4 that we're going to work through now. Sorry for the reflections, kind of had to figure out how to jimmy rig something to get this, to be able to show you how to do these on the whiteboard since we can't meet in person. So one of the problems, first one, is a cliff diver jumps off 27-meter cliff. Calculate the time of fall and the velocity. Okay, so you need to be able, sorry, that's my dog, to be able to figure out what type of problem that you have in order to move forward, right? When we did the zero initial velocity and non-zero initial velocity, we used clues in the word problem to figure it out. Now this one has a cliff, a jumper, and they're falling. So those are all clues that tell me this is going to be a free fall problem. All right, so we want to start by converting if necessary. So the only piece of information that I'm seeing is the 27 meters. Okay, it's in meters. Do we need to convert that? No, we do not. That's what we wanted in. So over here, I'm going to write my list of knowns and unknowns, and I have limited space. So that's why I'm not writing out each of these steps so specifically. So that 27 meters, that is a distance. And that's the only piece of information given to us from the word problem. But that's why it's important that you identify this as a free fall problem, because you're actually being given another piece of information. In free fall problems, the acceleration is gravity. And remember, gravity, Galileo discovered, was 9.8 meters per second squared. So that's the second piece of information that you can use just by identifying it as a free fall problem. So those are the knowns that we have. The unknowns are to calculate the time and the velocity. So time is represented by the letter T. Velocity is represented by the letter V. Once you have your knowns and unknowns, make a list. Figure out your equations. So if I want to figure out time, remember I'm using the zero initial velocity problems for free fall. I go through all of the equations, and the only one that I have that's going to work with the information given to me is this guy. Because I have distance, I have acceleration, it's gravity, and I need time. So we're going to have to rearrange this to solve for time. I want you to remember, and I mentioned this in class, that this is the same equation as that top one. This one's going to be a little bit easier to see how I rearrange it. All right, so I need t by itself. So I need this guy alone. So the first thing I'm going to do is I'm going to take this number 2. I want to get rid of it. To get rid of it, I need to multiply this side by 2. So since it's in the denominator, I'm moving it up in the numerator. Cancels it out on this side. I now have 2d is equal to at squared. So I need to get rid of a. I need to move it over to the other side of that equal sign. To get rid of it, I divide this side by a over a cancels. Whatever I do to one side of the equation, I have to do to the other. So now I have 2d over a is equal to t squared. T isn't by itself yet, it's squared. So to get rid of that squared, what can we do? Take the square root. So that's going to give me, move it back up here, t by itself, because that square root is going to cancel out that squared sign. It's going to be the square root of 2d over a. Now that it's rearranged to solve for t, I'm going to plug in the information I have over here. So I'm going to take the square root of 2 times 27, because that's what my distance is, divide it by my acceleration, which is the rate of gravity in this case, since it's free fall. And when I calculate that out, I get 2.347 seconds. A couple more after that. Okay, so I'm just going to stop there because I'm going to look back and see how many significant figures do I need. 1, 2, 3. I want 3 here. 1, 2, 3. Look at the number next to it. Does that stay a 4? No, it does not. So 2.35, and then the units on it are seconds. All right. Now, let's solve for velocity. To solve for velocity, we have an equation where v is equal to at. That's going to be the best equation for us to choose because we don't have to rearrange it at all. We have acceleration, we just solve for time. So now plug it in. I get 9.8 multiplied by 2.35. $23.03. How many sig figs do we want? Just the 3. Does this stay a 0? Yes, it does. So I have 23.0, and what are the units on velocity? Not miles per hour, but meters per second. So that is going to be our final answer there. All right, let's try another problem. So the next problem on the PowerPoint, get it written down here. The next problem we have is 2 rocks of different masses are dropped from a bridge and they hit the water 4.28 seconds later. Calculate the height of the bridge and velocity reached. So first thing you want to do is convert if necessary. This is the only piece of information given to us in the problem, explicitly anyway, and it's in seconds. Is that what we want it in? Yes, it is, so we do not need to convert. So let's look now at our knowns and unknowns. So 4.28 seconds is what? Distance, time, velocity, it's time, okay? And it appears that they did not give us any other information. They want us to figure out the height. And so when they say height, they're just looking at distance, d. It's going to be the same as distance. That's one of our unknowns. They also want us to solve for velocity. And that's represented by the letter v. Now notice, they're dropping these rocks from a bridge, dropping from a certain height. So what type of problem is this? Anything dropping or falling is going to be a free fall problem. So we also have another piece of information that we can add to our knowns, and that is the acceleration, which is gravity in free fall problems, that 9.8 meters per second squared. All right, so now we want to try to find some equations that are going to help us. So let's solve for distance first. So if I want to solve for distance, the equation that I can use is 1/2 at squared. I have a, that's gravity. I have time. Don't even need to rearrange it this time, so I'm just going to plug in my knowns, making sure to square the time. So I have 4.28 squared times 9.8 times 1/2. Gives me 89.76. Let's look at our significant figures. 1, 2, 3. So we want 1, 2, 3. Look to the number next to it. Does that stay a 7? It does not. It's going to go up to an 8. And what are the units on distance? Meters. Okay, so I'm going to add this over here. Right, so now let's try to solve for the velocity, the other unknown. So velocity from the last problem is just acceleration, acceleration times time. So don't need to rearrange this one either. It's 9.8 is our acceleration. Our time is 4.28 seconds. So calculating that out to 3 significant figures, we get 41.9. Units on velocity are not miles per hour, but meters per second. Rocks were going 41.9 meters per second. Now, notice there are 2 rocks. Do we need to calculate 2 different velocities? We do not, because remember that the law of free fall, Galileo figured out, the mass does not matter. All objects will fall at the same rate. So they will have the same velocity when they hit the water. They will land at the same time.